Okay, so this is the second part of chapter 4. Okay, so we have covered everything involving polynomial functions. So today we will do rational functions. Okay, so for rational functions, we have seen how to find the domain and range for rational function. So today we will focus on how to find vertical and horizontal asymptote, as well as how to sketch rational function. Okay, so let's start with definition of rational functions. Okay, so any function that can be written as a ratio, that means a fraction. So you could have a function on the top, another function in the bottom. Okay, but both of this must be polynomial. Okay, it must be polynomial divided by another polynomial. Then you will get a rational function. Okay, and remember definition of polynomial from before. Okay, is the degree must be integer and it must be positive. So you cannot have a negative degree, you cannot have rational degree, the power, okay? Cannot be rational, cannot be negative, okay? Those are not polynomial, okay? So the most basic rational function is 1 over x, okay? How does it look like? Like this graph. This is the graph of y equals to 1 over x. Okay, and notice that you will have two asymptotes. This line is called horizontal asymptotes. It's a straight line where the curve will never meet. So this part keeps going down closer and closer, but they will never cut like this. Never. Okay, they stay on top above, but become closer and closer. Okay, so this is an asymptote, horizontal asymptote. So in this case, the horizontal asymptote is your x-axis, where the equation of this line is y equals to 0. Okay. Also, we also have what we call as this line is vertical asymptote. Okay. This is exactly on y-axis. So the equation of this line is x equals to 0. If you notice this end, it keep going upwards, but they will never cut like this. Okay, they will stay on the side. Of course, it become closer and closer, but they will never meet each other. Okay, similar, this end down here, it keeps going downwards, but never cuts y-axis. Okay, so we have two horizontal asymptote and vertical asymptote. So today you're gonna learn, okay, because they don't always stay on this line. Okay, it depends on their functions. Okay, it depending on their function. So this is the rule or the guideline to find vertical and horizontal asymptotes. Okay, vertical asymptotes is the easiest. Okay, to find vertical asymptotes, you just need to focus on the denominator. Okay, and here is the numerator function on the top. D is the denominator function. Focus on the denominator. In order to get vertical asymptotes that are vertical, straight line but vertical, okay, what you need to do is you take everything in the bottom, your denominator function, and make it equals to 0. That's how you get your vertical asymptote. Just like before, for 1 over x, right? This is actually following the same rules. Okay, by taking x equals to 0, see, that's how you get x equals to 0 is your vertical asymptotes. What if I change? If I change my function to y equals to 1 over x minus 2, for example. So from the transformation of graph, before this you have learned that minus 2 from the x, meaning you should shift this to the left or right, class? Shift this to the right. Okay, that means this entire graph will be shift 2 units to the right, including the vertical asymptotes. Vertical asymptotes, it was at 0 before. So when you move 2 units to the right, it is now moved to the right by 2 units, like this. This is now your vertical asymptote, x equals to 2. So your graph now lying on this side, one here, and then one here. Okay, and how do we get x equals to 2? By taking the denominator function equals to 0. So if you take your x minus 2 equals to 0, then you will get x equals to 2. So this is your vertical asymptote. Okay, is that clear? For horizontal asymptote, you get the denominator function and then make it equals to 0. You could have, okay, let me give you another example. You could have a quadratic function in the denominator. Let's say fx is equals to 3x over x squared minus 5x plus 6, for example. Okay, so even though your denominator is not linear, we still follow the same rule. In order to find vertical asymptote, what do? Is you get the denominator x squared minus 5x plus 6, make it equals to 0. Then you're going to need to solve your quadratic equations. Can this be factorized? Yes, you will get 2 times 3 minus minus. So this time you will have two vertical asymptotes. One at positive 2, the other one is at positive 3. So your graph, okay, will be like this. This is your y-axis. So one asymptote is at 2. The other asymptote is at 3. So this is x equals to 3. Okay. So you would have two asymptote. We will learn how to find the asymptote first. Okay. Then we will learn how to sketch the graph later. Is that clear? Okay. That is for vertical asymptote. Now, for horizontal asymptote, the horizontal straight line where the curve never made. Okay, how do you find them? Okay, before this, I show you how to do it using long division. So you can see how much the graph has been shifted up or shifted down, right? But this time, you're not going to use division. We're just going to use these rules. Okay, there are 3 different rules here. It depends on the degree of the numerator, the leading degree on the top, and the leading degree in the bottom. That means the highest power on the top and the highest power in the denominator. Okay, so if your power on the top is smaller than the power in the bottom, okay, that means your horizontal asymptote will always be y equals to 0. That means it is still the x-axis, y equals to 0. Okay, when the power on the top is smaller than the power in the bottom. For example, this. The highest power on the top is power 1. The highest power in the bottom is power 2. Okay, so it's lower than the bottom. That means the horizontal asymptote is at y equals to 0. This is my horizontal asymptotes. Okay, how about the other function here? See, there's no x term on the top. So it's actually x to the power of 0 on the top. The highest power in the bottom is x to the power of 1. So this is lesser. That's why the horizontal asymptotes is lying on y equals to 0. The same case here. This is 1. Without the x, is independent of x. So it's x to the power of 0. Right? And then the leading power in the bottom is x power 1. So these are examples where the degree on the top is lesser than the degree in the bottom. Okay, so you don't have to think, you knew right away that the horizontal asymptotes is on x-axis. Is that clear? Okay, that's the first case. The second case is when your degree of the top, the numerator, is exactly the same as the degree of the denominator. So how do you get the horizontal asymptotes? You take the leading term on the top divided by the leading term in the bottom. Just divide them. But because the power are the same, later you will be able to cancel off. You can cross your x term. That leave you with the coefficient only. Okay, for example, let's see. Okay, this is example part B. The numerator function is 2x to the power of 2. So the degree is power 2 on the top. Meanwhile, in the bottom, the denominator function, okay, the leading power is also 2. So they are the same. So how do you get the horizontal asymptotes? You take the first leading in the front, divide by the first leading in the front. So that's going to be 2x squared divided by x squared. But you can cancel off your x squared, then you will get y equals to 2. This is your horizontal axis, horizontal asymptote. Horizontal will follow the y coordinate. Okay, so that will be the y values. Is that clear? Okay. Or another example, what if I have, let me give you, let's say if I have fx is equals to a cubic function, 3x cubed minus 2x squared plus 3x plus 10 divided by 2x squared minus 3x. Let me make it power 3 here. 3x squared plus 2x minus 5, for example. Okay, so let's say you have this rational function. And how do you get your vertical asymptotes? How do you get, no, not vertical, sorry. How do you get horizontal asymptote? Okay, for this case, the higher power on the top and the higher power in the bottom are the same. So your n is equals to your m. They are the same, which is just 3. So how do you get y is equals to, you take the leading coefficient, the leading term in the front on the top divided by the leading term in the bottom. So that will give you 3 of x cubed divided by 2 of x cubed. This can be cancelled off. So you got y equals to 3 over 2 is your horizontal asymptotes. So when you draw your graph like later, this is your x-axis. Okay, this is your y-axis. So your asymptote is at here. Asymptote must be shown with dotted line, dashed line, unless your asymptote is exactly on axis. So it cannot be seen, right? Okay, is that clear? This is the second case. When they have the same power on the top and in the bottom. So you just take the coefficient, divide them. Madam, do we have recording? Yes. Okay. We are recording right now. Okay. That is the second case. If the power are the same. The third case, what if the power on the numerator is bigger than the power of the denominator? For this case, there will be no horizontal asymptotes. You won't have horizontal asymptote. Okay, when the power on the top is greater. For example, let's say if I have x cubed minus 1 divided by 3x squared plus 5. So the power on the top is power 3, but the power in the bottom is power 2. So for this case, you won't have any horizontal asymptote. Is that clear? So there are 3 cases to get horizontal asymptote. So you need to remember the rules, whether you have lesser power, equal power, or bigger power. Okay, lesser power, then y equals to 0. Equal power, you take the coefficient on the top, divide by the coefficient in the bottom. If you're higher degree on the top, that means you don't have horizontal asymptote. Is that clear? So this is how to find asymptotes first. before we learn how to sketch them. Okay, let's look at example. Example, let's say we have this function. 2x plus 1 divided by x plus 1. Okay, how do you get vertical asymptote? Vertical asymptote by taking the bottom equals to 0. So if x plus 1 equals to 0, then your x is going to be equals to -1. So if you notice, see, this is already drawn. Observe the vertical asymptotes. It is at -1. Okay. Next, how do you get horizontal asymptotes? Remember the three rules just now. This is which case? The power on the top is power 1. The power in the bottom is also power 1. So this is equal power. So for equal power, when your n is equals to m, so how do you get your horizontal asymptotes? By taking the upper part, the leading only. 2x divided by x, so you will get y equals to 2. So y equals to 2 is your horizontal asymptotes. Now look at the graph. See, you have a dashed line at y equals to 2. Then you have one graph up here will never meet this dashed line. It will also never meet another dashed line here. Okay, so this is our graph. Is that clear? Okay, so you have to remember this rules. Okay, another example. Question A. 2x over 3x squared plus 1. Find all the vertical and horizontal asymptotes. So for question A, first find the vertical asymptote first. That's the easiest. Vertical asymptotes by taking the denominator 3x squared plus 1 equals to 0. Okay, and then solving for x, 3x squared is equals to -1. Okay, there's no solution to this, right? X squared equals to -1/3. There will be no solution to x. When there's no solution for x, meaning you do not have vertical asymptote. Okay, when there's no solution for x, that means you don't have vertical asymptote. But you might still have horizontal asymptote. Let's get horizontal asymptote. How do you get horizontal asymptote? By considering these three cases. Okay, which one is this? The power on the top is power 1 and the power in the bottom is power 2. So it's lesser than. So it's the first case. When the power on the numerator is lesser than the power in the denominator. Okay, 1 is less than 2. So your horizontal asymptote is at y equals to 0. It's on x-axis. Okay? Okay, that is for question A. Now for question B, let's find the vertical asymptote first. By taking the denominator, x squared minus 1 equals to 0. So x squared equals to 1. So you will be having two asymptote, plus minus 1. Okay, so you have two asymptote, x equals to 1 and x equals to -1. This is your vertical asymptote. Okay, so later when you sketch your graph, this is x-axis, this is y-axis. So you have one on the negative, one, the other one on the positive one. Okay? So you have two vertical asymptotes. Next, how do you get horizontal asymptotes? Now consider the power. The power on the top is power 2. The power in the bottom is also power 2. So they have equal degree. That's case number 2. When you have equal degree, so when n is equals to m, so your asymptote is at y equals to 2. In this case, is 2/1, right? 2x squared divided by x squared, that's just 2 over 1, which is just 2. No? Okay, so then when you include this on your y-axis, this is y equals to 2. So you have to make sure later when we sketch them, your graph will never touch all this dotted line. Okay? So that's why it's important that you be ready with your asymptotes first before we sketch them. Is that clear? So that is the first part that we need to cover today, how to get asymptotes for rational function, both vertical asymptote as well as horizontal asymptotes. Is that clear? Any
Yes.
questions on asymptotes?
Doctor, can you show me a part?
Can you show this one?
Yeah, okay. Done.
Part A? Part A, since there is no vertical asymptotes, that means later when you're ready to sketch, you just need to remember that your graph will never cut x-axis, yeah? But you don't have vertical asymptotes. So your graph could be either lying on top or lying in the bottom, but they will not cross, okay?
Okay.
Okay. Okay, let's move on to, oh yeah. See, this is the graph of the first one. It's already given. This is the graph of the first one, A. Okay, did you notice? Did you notice that you do not have vertical asymptotes? You don't have vertical asymptotes, right? That means there's no vertical line that they cannot make. Okay? But you have horizontal asymptote at y equals to 0. There. And also the second part for B, right? See, we should have two vertical asymptotes, one at -1, the other one is at +1. And then our horizontal asymptote is at y equals to 2. So if you look at all the graph, all this curve never meet the dashed line. So next, we're going to learn how do we get this curve? How would you know this is supposed to be up here? And why is it not down, right? And this curve, why is it in the bottom? Why is it not up here? Right? It could be the other way around. So, right? So how do you know it's not here, and it's not here? Okay? So we will learn how to get this. Okay, another example. Another example of rational function. Okay, let's get the vertical asymptote first. Vertical asymptote is the easiest. How do we get them? By taking the denominator, x squared plus 3x plus 2 equals to 0. And this is quadratic equation. See if we can factorize them. Yes, 2 times 1 is 2. And then I can get 3 by plus both, right? So we have two asymptotes at x equals to -2 and x equals to -1. Okay, see? So this is the one that I already sketched. One asymptote at -2, and the other vertical asymptote is at -1. Next, I need the horizontal asymptote, the HA. How do you get horizontal asymptote? By comparing the highest power on the top. Highest power on the top is 1. Highest power in the bottom is 2. So this fulfill the first condition here. The power on the top numerator is smaller than the power in the bottom. So our horizontal asymptotes will be on x-axis. Okay, y equals to 0. So n is equals to m. So y equals to 0 is our horizontal asymptote. So this is actually an asymptote. Exactly on x-axis. Okay? And then now later I will teach you how do I know that I should have, because you have like this, right? Like you have different block. So you need to know where you place your graph correctly. Okay? So I'll teach you later how do I know that I get one graph here, one graph in the bottom, and then one graph over here. Okay? So we will do that here. Okay, I didn't find the notes about graphing rational function from the slide, but this is from the book. Okay, this is from the book, the module. Okay, so this here we will follow step by step on how to graph rational function. Okay, there are 5 steps. The first one, get the x-intercept first, okay, because you needed to know where your graph cuts x-axis. And then you also need your y-intercept, okay. How do you get x-intercept? By substituting y equals to 0 into your function. Then you will get your x values. Okay. Meanwhile, to get y-intercept, you substitute x equals to 0. See? You substitute x equals to 0, then you will get your y. When x is equals to 0, you will get what is your y value. So intercepts is always important. Okay, once you get both the intercepts, next, okay, you're gonna need to find your asymptotes, the one that you just learned just now. Okay, get the vertical asymptotes first. This is the easiest. Okay, by taking the denominator function equals to 0. Then you will get your x values. Okay, and then next, get your horizontal asymptotes. How do you get horizontal asymptotes? By comparing the power. Remember, there are 3 cases just now. When n is less than, when n is equal, and when n is more than. Okay? So your asymptotes will depend on these cases. So once you got your asymptotes, both vertical and horizontal, then lastly, we will construct a table, okay, using test values. So this is important because the test values will tell us whether our graph should be lying above x-axis or below x-axis. Okay, so there will be 5 steps. Let me show you with example. Okay, let's look at this example. Sketch the graph of 2x divided by x squared minus 1. So let's do step by step. Step number 1, let's get the x-intercept. How do we get x-intercept, class? By taking y equals to 0. So if you take your function fx, 2x over x squared minus 1 equals to 0, I can bring the denominator to the other side. That becomes 0 as well, right? So that's gone. No more denominator. So that leaves you with only 2x equals to 0. So solving for x, then your x must be equals to 0, right? Because x 2 times 0 is 0. So you have your x-intercept, whereas the coordinate is 0, 0. Because you got 0, 0 here, then later when you find y-intercept, it's going to be 0, 0 as well. Okay? If you don't believe me, you can substitute x equals to 0 here. Then what will you get? Your f0 will be 2 times 0 divided by 0 minus 1. So that's 0 over negative 1. 0 divided by anything, it is still 0. So that's why your y is also 0 here. Still, it's referring the same point. So your x-intercept and y-intercept is at the same point, which is at the origin. Okay, now that we got the intercept, any questions? Now that we got the intercept, okay, next you need to find the asymptote. Okay, vertical asymptote is the easiest. How do you get vertical asymptotes? By taking the denominator function, the one in the bottom only. X squared minus 1, make it equals to 0. Then solving for x here. This is differences between 2 square, correct? 1 is actually 1 square. So you can simplify this as x plus 1 and x minus 1 equals to 0. Therefore, you will be having 2 vertical asymptotes. One at negative 1, the other one is at positive 1. So you will have 2. Okay, next, how about horizontal asymptotes? What is the degree on the numerator? The top is degree 1, the bottom is degree 2. So your n is lesser than your m. Your n is lesser than m because your n is 1, your m is 2. So do you have any horizontal asymptote? It will follow the first rule. Your horizontal asymptotes will be at the y equals to 0 on x-axis. Okay? Now done. We have the intercepts and we have all the asymptotes that we need. Okay, next is, okay, we need to form a table using test values. Okay, I am using a number line. So this is our number line, x-axis. And you have to divide your x-axis into a several partition. So this partition is determined by your vertical asymptote. Just now, we have two vertical asymptote, one at -1 and another one is +1. But in between, we have the y-axis, right? So you always need to separate your y-axis. So I'm going to split this. So x0 is here, x-1 is here, and x+1 is here. Okay, so when you do this, now we have how many partition? 1, 2, 3, 4. Okay, so you end up having 4 different partition. Okay, then what do we need to do is, next is, I'm going to pick test value. Test value is, you have to pick one value in each partition, in each interval. Like the first interval here is, you can pick anything that is lesser than -1. So I'm going to pick x equals to -2 here. For example, you can pick any other than -2. You can pick -3. As long as this value that you pick lying in the interval. Okay. For the second interval, I can pick, what is the number that I can pick here? Between -1 to 0, I can pick -1/2. Now between 0 to 1, I can pick half, +half. And then after 1, I can pick 2 or you can pick 3. Doesn't matter. Okay. So test value, you just pick one value in each interval. And then what we're going to do is, okay, I teach you how to use your calculate button last time, right? Okay, this is when you're going to use calculate button again. Because what you're supposed to do is, you're supposed to substitute your test value into your fx function. Because we wanted to know what is the sign of our fx values. Okay, so this is when we need to do substitution. Wait, let me get, okay, give me a second. Let me get my calculator. Okay, I found it. Okay. So use your calculate button so that you can do it very fast. Okay, so what you need to do is, class, okay, you key in this function 2x over x squared minus 1 in your calculator. Okay, I'm doing it right now. X squared over, no, not x squared. 2x. Key in this function, yeah? 2x over x squared minus 1. Okay, and then press calculate button. So the first x values that I want to use here is -2. So when you press -2, what will you get? You will get your y values right away. What do you get? I got fx, okay, let me just write it down here. Okay, I've got f -2 equals to -4/3. Is that correct? Should you get the same? So negative, right? I just needed to know the sign. So I end up getting y value that is negative. So you just take note here, this is negative. Okay? And then now change the x value. Okay? Do it for another test value here. So press the calculate button again. Now change your x to negative half. Negative 0.5. What will you get now? I got positive f of negative half. This time I got positive 4/3. So this is positive value of y. Okay, now change it again to the next test value. X equals to positive half. What will you get? This time I got negative value. F of half is equals to negative 4/3. So it is negative in this region. Lastly, change it your x to 2. This time I got F2 is equals to positive 4/3. So this is now positive. Okay, how is this sign useful? So Fx is referring to the y coordinate, correct? Y values here is referring to our y coordinate. So if your y is negative, that means the entire graph before -1, they will be all on below x-axis because they are all taking negative y values. Meanwhile, for the region between -1 to 0, because the sign of your y values are positive, that means this time the graph will be lying above x-axis. This one will be below, this one will be above. Okay? So this test value table actually telling you where should you sketch the graph. Okay, above or below x-axis. So roughly, I will be able to, yeah, okay, this is our y-axis. This is my asymptote. I have asymptote at x equals to 1. I have asymptote at x equals to -1 as well. And then our, what was our horizontal asymptote is exactly on x-axis. So I will have a horizontal asymptote here. And then my intercept at the origin. So whatever I do, I have to make sure that later my graph will cut at origin. So now how do I sketch the curve? So first, the region before this side, before x equals to -1, their y coordinate are all here, right? So your graph must be down here in the bottom. Okay? You cannot draw graph like this. Because if you draw like this, then here, this tail will be meeting the asymptote, which is we are not allowed to meet the asymptote. So that's not possible to draw graph the blue one. That's why our graph is like this. This going downwards, okay, without meeting x equals to -1. This going outwards without meeting y equals to 0. Okay, that is the first part before -1. Now, okay, I'm ready to draw from -1 to 0. Okay, this region. From -1 to 0, the y values are positive. That means I cannot draw anything down here. My graph must be lying above, right? And then what happened after? So when your graph is lying above here, so there's two possibilities. Whether you're going to have a smiley curve like this, okay? Or you're going to have graph like this. Which one is it? This is the correct one. Why? Because between -1 to 0, your graph is supposed to be above x-axis. And then between 0 to 1, your graph is supposed to be below x-axis. So it's going downwards. Okay? This is the only shape that is possible so that both ends didn't meet the asymptote. This didn't make x equals to -1, and this still didn't make x equals to +1. Got it? Okay? Just in case, if you have plus plus here, that means your graph will look like this, smiley curve. If your graph is minus minus, then you'll be a sad face down here. Okay? That's why this sign is very important. Okay, and then lastly, for x be after 1, for x that is greater than 1, okay, on the right side of 1, okay, because the y coordinate are all positive. So you cannot draw graph down here. Your y are all positive. So it's somewhere in here. But how do the graph looks like? Remember, you have horizontal asymptote that you cannot touch here, and you have vertical asymptotes that you cannot touch here. You cannot draw something like this, cannot. They will touch, okay? So the only way that they didn't touch both of this line is you draw curve like this. Okay? Done. So this is how the graph of fx looks like. This is our y equals to fx function, the rational function. Is that clear?
Repeat how you did it in the calculator.
Sorry, what was the question?
Can you repeat how we can do it on the calculator?
How to press the calculator? Okay, if you are using, okay, different calculator will have a different way of pressing them, but I'm using Classwiz. This is Casio 570EX. Are you using this calculator?
Yes.
Yes. Then what you need to do is on the screen, on your screen, right? You key in 2x over x squared minus 1. Okay, once you have seen this on your calculator, on the screen of your calculator, what's next is you press the calculate button. Did you see calculate button? It's just beside the option.
Yeah.
Okay, so once you press calculate button, what do you see on your calculator? Suddenly down here, it will appear on your screen, right? You will see this, your function is still up here, x squared minus 1. And then suddenly down here, they will ask you x equals to what? Correct?
Yeah.
Yeah, so your job is to key in the x value that you want in here. Your test value. See, you have, in this case, I have 1, 2, 3, 4, 4 test value. So key in the first one, x equals to -2. So if you key in x equals to -2 here, you have to press equal button twice. Why do we need twice? Because the first equal to confirm your x value. The second equal, this is when you get the answer. After you press the second equal button, you would see that they give you this value, -4/3. Did you get it?
Yeah.
Right? Okay. So next, to change the next new x values, right? You just need to press the calculate button again. Every time you need to use the same function, still the same function, but you just need to change the x values. You just press the calculate button again. You repeat this step and then key in the new x values. Okay, this way is faster. Okay, if not, you're gonna have to key in like 2. Okay, if your x is -2, right? So what student normally do is they will key in 2 times -2 divided by -2 square minus 1, and then press equals 2. And then they cannot use this again. Okay, then the next time they have to change the x to -half, then change it again. So you have to keep pressing the same thing over and over again. Okay, that's a waste of time. Okay, you have that function in your calculator, so please use your calculator. Okay, is that answering your questions? Okay, that is to get your y values down here. And I just need the sign, whether they are positive or negative. Is that clear?
Yeah.
Okay, let's do one more example. This is also from the book. Sketch this graph. Okay, let's do the 5 steps. What is the first step, class? Find the x-intercept. How do we get x-intercept? By taking y equals to 0. So x square over x square minus x minus 2, this is equals to 0 entirely. Okay, I can eliminate the denominator. This will be gone when I bring it to the other side, right? Anything multiplied by 0, it's still 0. So that's gone. That leaves me with only x square equals to 0. So my x is equals to 0. So my intercept is at origin, again, 0, 0. So for this case, when your intercept is at origin 0, 0, that means you don't have to find y-intercept anymore, right? There's no point. This is x-intercept. At the same time, this is also y-intercept. Okay? So let me just combine. This is x-intercept and y-intercept. So step 2 is done already. Now step 3 is finding vertical asymptote. How do we get vertical asymptote? By taking the denominator function and make it equals to 0. So x squared minus x minus 2 equals to 0. You get to solve for x. Can this be factorized? X 2, 1. What is the sign? Negative 2, positive 1. Correct? Then you would have two vertical asymptote. One at 2, the other one is at negative 1. So there are two vertical asymptote. Okay, step number 4 is to find horizontal asymptote. Find horizontal asymptote using the rule. Look at the highest power on the top. It is power 2. And the highest power in the bottom is also power 2. So when you have the same power, what do we do? When your n is equals to m, what do we get? The y will be equals to the leading coefficient in the front. This is 1, right? This is also 1. So 1 divided by 1, or you can do x squared divided by x squared. That is just 1. So your horizontal asymptotes is at y equals to 1. It's above. Okay, it's not on x-axis anymore. Okay, done. So we got all the intercepts. We got all the asymptotes that we need. Now, the last step is the test value. Step number 5. Okay, test value, I will start with the number line. Okay, the zeros. Okay, x equals to 0. And then the vertical asymptotes. We have vertical asymptotes at 2 and at negative 1. So I will add negative 1 somewhere here, positive 2 here. So this will separate our number line into 1, 2, 3, 4. 4 different partitions. Now you can pick your test value. Let's choose the test value accordingly. So for the first region here, I'm going to use negative 2. Here I can use what? Negative half. Here I can just use 1. And here I can use number 3. Okay, this is my test value. Next is, okay, this time we are going to use the calculate button to get the fx values. Okay, calculate button. So let me key in. Key in this in your calculator. The function x squared. Okay, x squared over x squared minus x minus 2. Okay, and then press calculate button. Let's do together. Okay, key in the first test value. My first test value is negative 2. So when you key in negative 2, press equal twice. What is the answer that you get? 1, right? So your f of negative 2 here, the answer is equals to 1, which is positive. So just note the sign up here. It is positive. I mean, later when we sketch them, you need to be aware that the curve for x lesser than negative 1, this will be lying above x-axis because they are all positive value. Okay? And then between negative 1 to 0, okay, now change the test value to negative half. So press calculate button again, change it to negative 0.5. What do you get this time? I got f of negative half. This gives me negative 1 over 5. Correct? So it is a negative values. So I just jot down negative sign out here. Okay? Next, change another next test value, x equals to 1. So calculate x equals to 1. That will give me negative half. So here, f of 1 is equals to negative half. So the value is negative. It's negative here. Okay, and then after 2, now change the test value to 3. The last one is x equals to 3. Okay, press equal twice. What will you get? I got f3 here is equals to positive 9 over 4. So it is positive again here. Okay, now that we have the sign, we are ready to sketch the graph. Okay, let me just copy this. I don't have enough space. Okay, so with this information, I can now start sketching the graph. Okay, this is my x-axis. My y-axis is when x0. And then remember, we are supposed to have vertical asymptotes at -1 and at +2, right? So you have to draw the dashed line. 1 at -1. This is x equals to -1. And this is at +2. X equals to 2. And remember, we are supposed to cut the graph at the intercept is at origin 0, 0. So remember, you have to meet this point. Okay, it will pass us through this point. So let's go through the first partition on the left side here. Okay, what happened before -1? Look at the sign. What happened before -1? The y values are positive. So you cannot draw any curve down here. Your curve must be up here. So how the curve looks like. And remember, you have horizontal. Wait, where is my horizontal asymptote? I forgot about this. We are supposed to have horizontal asymptote at y equals to 1. So I'm missing out the horizontal asymptote. So you have to draw a dotted line at y equals to 1. Okay? So now, since you could not draw the first partition here, right? Before x equals to -1, your y, the values of y are positive. So you could not draw anything down here. And since you have a horizontal asymptotes, you cannot draw anything here as well because you cannot have a graph that passes through this line. Cannot. So you are not allowed to draw anything in this region. You can draw something up here. But how does the graph looks like? Because you have a horizontal asymptote and a vertical asymptote here, the only graph that is possible is like this, isn't it? So that this end is approaches the horizontal asymptote, the other end approaches the vertical asymptote. Okay, you cannot draw something like this. That will surely cut and meet the asymptotes. Okay, so your graph will be this. So 1 is done. Okay, next, moving on. Now, between -1 to 0, what happened? Between -1 to 0, we have two regions, up here and below here. Our graph is supposed to be negative, lying down here, somewhere in the negative region. And since between 0 to 2, it's also negative. That means when you come from down here, remember you have to meet the 0, right? Okay, you have to meet the 0. Can you continue going up? Are you allowed to continue going up? This one? Cannot, because this is already above x-axis. And remember, for this region, the sign of your y is negative. That means you cannot, after you meet the 0, right? You cannot continue going up. You have to turn around so that your y remain negative. See, your graph will be something like this. That's one touches, yeah? Okay. Negative means below x-axis. This negative is also below x-axis. Okay. So done. We did until 2 already. Now what happened after 2? On the right of 2, the y values are positive. So you cannot draw anything here. It must be here. And remember, you have two asymptotes, vertical and horizontal asymptotes. So the only functions graph that will not meet these two asymptotes, it must look like this. So the right tail is going towards the horizontal asymptotes. Meanwhile, the left tail up here, okay, it become closer and closer to the vertical asymptotes. Okay, so this is how our graph looks like. This is the graph of y equals to fx. Done. Is that clear? Any questions, class? Any question? Is that clear or not? No.
Yeah.
Okay. Okay. So the example is done. Now let's do the 5 questions from the tutorial. Can we have 5 minutes break? Okay. And then we will do the 5 tutorial questions. I'll come back after 5 minutes, yeah? Okay, let's continue with the tutorial questions. Okay. Sketch the graph of the rational function. Okay, let's follow the same 5 steps before. Okay, so the first step is getting the x-intercept. How do we get x-intercept? By taking y equals to 0. So if your y is 0, then this entire thing, x minus 1 cube, is going to be equals to 0. Do you have x-intercept? In this case, when you bring this to the other side, then you end up getting 1 equals to 0. That's absurd. That cannot be happening. 1 is not equals to 0. Meaning there's no solution to this. There's no x value that can give your y becoming 0. So when there's no solution of x, meaning there will be no x-intercept. You won't cut x-axis. Okay? Next. Step number 2 is getting your y-intercept. We can get y-intercept by taking x equals to 0. So our f0 will become 1 over 0 minus 1 that you cube. That is 1 over negative 1 cube is negative 1, yeah? Careful. So 1 divided by negative 1, that's going to be negative 1. So you will have y-intercept at y equals to 0. So you have to cut this point. The x is 0, the y is negative 1. Okay, so remember later when we sketch the graph, make sure we cut y at this point, at negative 1. Okay, so we got our intercept. Next is, let's find the vertical asymptote. How do we get vertical asymptote? By taking the denominator function and make it equals to 0. So we have x minus 1 cube equals to 0. So x minus 1 is 0, then x is equals to 1. That means you have only one vertical asymptotes. Next, number 4 is get the horizontal asymptote. How do you get horizontal asymptote? By comparing the power of your polynomial. So the one on the top is the polynomial degree 0. The one in the bottom, this is polynomial of degree 3. So this is less than, right? The top is less than the bottom. So this is the case where your n is lesser than your m because 0 is less than 3. So for n that is lesser than m, our horizontal asymptote is always on x-axis. So it's at y equals to 0. So we got the intercepts and the asymptotes. Now we are ready to do the test value number 5. Let's do the test value to get the number line. Let me continue. Okay, let's do the number line. This is x. This is 0. Now, just now we only got one vertical asymptote at 1. So that's 1 here. So this divide our region into 3 different partition. 1, 2, 3. Right? Okay. So now you can pick the task value that you like to use. So for the first region on the left of zeros, you can pick -1, right? In here, you can pick -half. No, that's positive. Sorry, it's positive. And then after 1, you can pick 3. Okay. And then now we're going to use our calculate button. Okay. So let me key in the function first. What was the function again? It's 1 over x minus 1 that you cube entirely. Okay. So now let's substitute in to get the fx function. So f of -1 here, when you press calculate button and then key in x equals to -1, what will you get, class? What do you get? -1 over 8. So that is negative value. Now between 0 to 1, we change, calculate x to 0.5 now. This one I got f of half, I got equals to -8 here. So it is negative again. Now after 3, calculate, key in 3, I've got +1 over 8. So f of 3 here, I got +1 over 8. So this is positive now. Negative, negative, positive. Okay, now that we have the sign, we are ready to sketch them. That's x-axis. That's y-axis. Asymptote is at 1. X equals to 1. Okay, now how do you draw the first one from anything that's coming from the left towards 1, right? They are all negative. So you cannot draw anything up here. Must be something down here. And remember, we have horizontal asymptote on x-axis on this line. So if you were to draw something down, here, and the curve cannot meet these two lines, so it must be something like this, correct? And remember, we got y-intercept just now. The y-intercept is occurring at -1. So that means the graph will look like this. This going downwards, this going upwards, and this cuts at -1. Right? Okay, because you have two asymptotes, the horizontal and the vertical. So both ends cannot cut these asymptotes. They cannot meet each other. Okay, so done until 1. Now moving on, after 1, on the right of 1, because the y values are positive. So you cannot draw anything down here. Must be something up here. Okay, and remember you have this asymptote and this asymptote. So the only shape that didn't meet these two must be like this. Okay, so that's why the graph is up here. So the right tail is towards horizontal asymptote. The left tail, as it goes outwards, it's become closer and closer, approaches the vertical asymptotes. Okay, approaches only. They never meet. Is that clear? Okay, so there's no x-intercept because x-axis is our asymptote. Yeah, that's why we didn't get solutions to this. Okay, question 21 done. Any questions? No, I got one thumbs up means okay. Okay, moving on to questions 2. Okay, 22. Okay, again, the same 5 steps. Step number 1, get the x-intercept. How? By taking y equals to 0. So remember, the bottom will be eliminated once you put it to the other side. So I just focus on 3x squared plus x minus 4 equals to 0. Can this be factorized? 3x and x, 4 and 1. That can give us positive 1. So that's going to be plus minus, correct? Okay. So we have two x-intercept. Is it true? Let me check for x minus 3x. Correct. Okay. So x equals to 4, negative 4 over 3. And x equals to 1. Plus x minus 4. Correct. Okay. Let's see this one first. Next. Questions, steps 2, we need the y-intercept. To get y-intercept, we substitute in x equals to 0. So when x is equals to 0, so every time you see x, this now becomes 0, 0, 0, 0. So what's left is negative 4 over 5. Negative 4 over 5. So we have y-intercept at negative 4 over 5. Next, we need the vertical asymptotes. How do you get vertical asymptotes? By taking the denominator equals to 0. 2x squared minus 7x plus 5 equals to 0. So when you factorize this, can this be factorized? See, 5 and 1, that can get me 7. Minus minus, right? So I'll have x equals to 5 over 2 and x equals to 1. Okay, so since this is vertical asymptote, that means x here cannot be equals to 1. This will be rejected. Okay, that means later your x-intercept, they will only meet x at 1 value only. So that's our x-intercept, that's our y-intercept, and we have 2 vertical asymptotes. Okay, step number 4, let's get horizontal asymptote. How? By checking the degree. The degree on the numerator and the degree in the denominator, they are the same. So this follow the second rule, right? When the n is equals to m, so how do you get y? By taking the leading coefficient on the top divided by the leading coefficient in the bottom. So when you cross out the x squared, so that's how you got y equals to 3 over 2. So this is where your horizontal asymptote is. Okay, now that we get all the asymptotes and intercepts, next we can continue with the number line to test value. Test value, but before that, if this is 0, just now we've got 2 vertical asymptote at 5 over 2 and at 1. 5 over 2 is 2.5, right? So both of them is on this side. So 1 and 2.5, 5 over 2. So this divide the number line into 1, 2, 3, 4 different partition. Let's pick one test value for each interval. So I'm going to pick, let's say, x equals to negative 1 in here. This is x equals to positive half. This is x equals to 2. I can pick 2 here. I can pick 3 or 4 here. Okay. Okay, let's now get the fx value. What is the value of f negative 1? Okay, let me key in the function in my calculator first. Key in this, I would get 3x squared plus x minus 4 divided by 2x squared minus 7x plus 5. Then calculate button. Now let's start with the first test value, x equals to negative 1. So what will you get? I got f negative 1 is equals to negative 1 over 7. So the sign here is negative. Now change another test value, positive 0.5. This gives me negative 11 over 8. So this is also negative. Now change to positive 2. This one I got negative 10. So this is still negative. And then 4. Calculate x equals to 4. This is now positive. I've got 16 over 3. Positive. Let me double check. So negative, 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 and the last one is positive. Correct. Okay, got the correct sign. Now we are ready to sketch them. This is our x-axis. This is my y-axis. And we have one vertical asymptote at 1, x equals to 1. And then the other one is at 5 over 2. And where is our horizontal asymptotes? It is at 3 over 2 up here. Let's say this is notation. Okay, let's say this is my y equals to 3 over 2. And later, okay, where is our intercept? The x will cut at negative 4 over 3, and the y will cut at negative 4 over 5. So both on the negative side. X will cut somewhere here, y will cut down here, like this. Right? So to be able to cut these 2 points, your graph must look something like this, isn't it? They are all negative. Here. This is negative. So it must be down here. Wait. This is x equals to 0. Is this negative? Let me check again. Calculate x equals to negative 1. Negative. If I calculate x equals to, it's negative. Three x squared plus x minus 4, 2x squared minus 7x plus 5. before 0. So x squared minus 7x plus 1. Did you get negative here? Calculate negative 0.5. It's negative. It's below. It must cut x at negative 4/3. And it cuts y at negative 4/5. So it looks like this. It's equals to 1 and x equals to 5/2. Mm, Check this is correct, right? Negative 5x and negative 2x, negative 7x. This is positive 5 and correct. We over to 4. Wait, between 1 to this is negative. We didn't cut any more x, right? It's only one x-intercept. Okay, let me check this one first. Okay. Let me check this one first. Okay, let's do the next questions. Okay, let's do question 23. Can this be simplified? Let me factorize this first. 2x and x, 3 and 1. So 2x minus 3 plus 1, right? And then the one in the bottom, this should be x times x, 2 times 1 plus plus. Oh, no wonder. Okay. Okay. So you should factorize first before you continue, because it's possible that you have the same factor on the top and in the bottom. So that's actually can be crossed out. I think that is the same for these questions. That's why I have trouble here. Okay. We are supposed to factorize them first and then simplify the equations. So now fx can be reduced as is just 2x minus 3 divided by x plus 2. There are equal root on the top and in the bottom. Okay, if you notice from the previous questions just now, that's why I've got x equals to 1 here and x equals to 1 in the bottom as well. I am supposed to factor out, cancel them out first. 3x plus 4 and x minus 1, right? Divided by, in the bottom, I have 2x minus 5 divided by x minus 1. So there's no more actually. Yeah. Okay. Okay. So let's do it correctly. Let's start. Okay. So we will deal with this and then we will do the 5 step. Okay. Step number 1, I need the x-intercept. So my x-intercept is 2x minus 3 equals to 0. So 2x is 3, then x is 3 over 2. Step number 2, I need the y-intercept. Y-intercept occur when x is equals to 0. So f0 will become 0 minus 3 divided by 0 plus 2. That's going to be negative 3 over 2. So our y is at negative 3 over 2, y-intercept. Next, step number 3, we need the vertical asymptote. Vertical asymptote is found by taking the denominator equals to 0. So your x is equals to negative 2. So you have one vertical asymptote at negative 2. And for step number 4, horizontal asymptote, now we compare the power. So the highest degree on the top is 1. The highest degree in the bottom is 1. So they are equivalent. So when they are equal, and when m is equals to n, we take the y is going to be equals to 2x over x, which is equals to 2. Y equals to 2 is our horizontal asymptote. Now we have all this. I can do the test value. Step number 5. X-axis 0. The vertical asymptote was at negative 2. Negative 2. Somewhere here. So that divide into 3 partition. Okay, let's do test value. Okay, let's pick one value for each region. Let me use negative 3 here. This is negative 1. I can use positive 1 over here. Now use calculate button. I'm going to key in the simplest one, this one. No need to key in the original function. 2x minus 3 divided by x plus 2. Calculate. Okay, I want my first test value is negative 3. So f of negative 3 here is equals to, I've got positive 9, so it is positive. Now change the test value to negative 1. So f of negative 1, I got negative 5. So it's negative here. And then the next test value is 1. So calculate 1, I got negative 1/5. So it is negative here now. Okay, we've got the sign. Now we are ready to sketch the graph. So x-axis y-axis is at 0. And then asymptote is at -2. X equals to -2. The y asymptote was now little at y equals to 2. The horizontal asymptote is at y equals to 2. Let me draw. This is my y equals to 2. And then just mark. Note that you're supposed to cut x at 3/2, cut y at -3/2. Would be somewhere x at 3/2 and cut y at -3/2. Right? Okay, so now we can sketch them. So the first region before -2 here. So since the graph, it's positive value. The y are taking positive value. That means you are allowed to sketch here, not here. Okay? That means the graph will look like this, going upwards. Okay? Meanwhile, the other graph down here, see between -2 onwards to the right side, they are all negative. That means they are all below here. So you can sketch below. Okay? That clear? You can actually add another one partition here because your x here is 3/2, right? So if you add 3/2 here, then you can pick one more test value. 3/2 is 1.5. Maybe you can pick 2 here. So if you press, you still have your calculate function. If you substitute 2 into, and this time you get positive F2, you get positive 1/4. So that's why this graph, after 3/2, the graph is above x-axis. Okay? So you can actually add your x-intercept if you have x-intercept. You can add your x-intercept on the number line to get the test value. Okay? Okay, this is question 23. We've got 2 more. Okay, jump. "24. Okay, the 5 steps. Step number 1, x-intercept by taking 5x plus 3 equals to 0. Then 5x is -3, so x is -3/5. That's our x-intercept. Step number 2, to get the y-intercept, we take x equals to 0. So f0 will become 0 plus 3 over 0 minus 3. That's -3/7. Okay, so this is our y-intercept. Okay, step number 3, vertical asymptotes. How? By taking the denominator equals to 0. So 3x is equals to 7. Now x is 7/3. So you have one vertical asymptote. And for horizontal asymptote, step number 4, we compare the degree on the top and the bottom. They are the same. So when n is equals to m, for this case, what we do, we get the y by taking the leader on the top divided by the leader in the bottom. That gives us y equals to 5/3. Okay, so we got one horizontal asymptote as well. Okay, now step number 5, I need the number line. Okay, how many we should divide our number line into? So we have one vertical asymptote and we have one intercept. So I'm going to divide them into 0, the 7/3, and our zeros was at -3/5. So that's divide into 1, 2, 3, 4 partition. Okay, so let's add test value that you want to use. Okay, let me pick 3 over 5 is about 0.6. I can use negative 1 here. I can use negative half. Here I can use 1. And here I can use 3. Okay, now use your calculator. Key in the function 5x plus 3 over 3x minus 7. Calculate. Now let's key in our test value. So f of negative 1 here, it gets us to positive 1 over 5. So it is positive. And then f of negative half here, it gets me to negative 1 over 17. So this is negative. So F1 here, calculate x equals to 1. I got negative 2. So this is negative. And then F of 3 here, calculate, change x to 3. I've got positive 9 here. Okay, let's just double check again the sign. Positive, negative. Before 0. Negative, positive. Correct. Okay. Now we are ready to sketch them. That's our x-axis, y-axis at 0. Now, what is our asymptote? At 7 over 3 here. X equals to 7 over 3. And then our horizontal asymptote is at 5 over 3. Say this is our y equals to 5 over 3. Okay. And then we have intercept. The x-intercept is at negative 3 over 5 here. It will cut here. And on y, it will cut at negative 3 over 7 somewhere here. So when you sketch your graph, it looks like this. Positive is above x-axis, cut this, and going downwards. Here, going down, cut the first intercept, second intercept, and then going downwards. Okay. So if you check the number line, see this region, this part, the curve are all above x-axis. And then this is when it's below x-axis. This is also below. Okay, so just label your x-intercept is at negative 3 over 5. Your y-intercept is at negative 3 over 7. Okay, and then now what's after 7 over 3? They are all positive. That means it must be here. Okay. Okay, done. Okay, last one. Let's do it very fast. Last graph rational function. So question 22 just now, you correct it on your own. Okay, make sure you cancel off the equal factor first. Similar like question 23. Okay, this one. Okay, the 5-step. X-intercept. How do you get x-intercept? By taking y equals to 0. I will have 2x squared. Wait, Can this be factorized? Let's double check. 2, 2x times x, 1 times 1. Negative, positive here. Okay, so we don't have equal factor, yeah? We don't have equal factor. That means, okay, I can continue. 2x squared minus x minus 1 equals to 0. And factorizing this, 2x plus 1 and x minus 1 equals to 0. I will have to intercept. X equals to negative half. And one more is x equals to positive 1. Okay, now to get step number 2, I need the y-intercept by taking x equals to 0. So my f0 will be negative 1 over negative 2, which is positive 1 over 2. Okay, substitute x 0, 0, 0. Okay, that leaves you with negative 1 over negative 2. Now we got the intercept already for asymptotes. Vertical asymptotes, taking the denominator equals to 0. So you have 1 vertical asymptotes. Meanwhile, for horizontal asymptote, step number 4, now we compare the power. Oh, this time, the first time, the power on the numerator is higher. Your n is higher than your m. The power on the top is 2, the power in the bottom is 1. So in this case, you do not have horizontal asymptote. This is the third case. Okay, next, now we can do the number line. Test value. 0. Vertical asymptote is at 2, but we have to, I will include the y-intercept as well. At 1 and at negative half. 1, 2, and negative half. So this will divide our test into 1, 2, 3, 4, 5. Okay, let me choose 1 here is negative 1. This is negative 1/3. This is positive half. Let's say 1.5. And this we can take 3 or 4. Okay, now very quickly, press your calculator. 2x squared minus x minus 1 on the top, divided by x minus 2 in the bottom. Okay, calculate and then get the sign. Okay, I'm going to get the sign right away. X equals to negative 1. This gives me negative. X equals to negative 1 over 3. This gives me positive. And then positive half. This is positive. Positive 1.5. This is negative. And lastly, positive 3. This is positive. So now I'm going to take this to the next page and be ready to sketch them. Okay. We don't have horizontal asymptote, right? X, Y. But we have two or one. One vertical asymptote at 2. Here. X equals to 2. But the graph will cut at 1 and at negative half. At 1 and at negative half. They will cut twice like this. So before this, it is below, right? Negative. And then after this point is now above. Did you notice before the intercept, right? It was below here. After that, it is above. This is still above. And then after the second intercept, it is now below. So your graph will look something like this. Just now you have y-intercept, right? Yeah, that's match. Y-intercept was at positive half. Yeah, so your graph will looks like this. And it cuts at positive half. Okay, so meanwhile, the other graph after two, they are all positive. So there will be another graph up here. Okay, so that's why you don't have horizontal asymptotes. Okay, this is not horizontal asymptotes because it's not approaching. Okay, done. So this is the last questions in the tutorial. Okay, so done with the rational function. So those who are asking about the lecture again, okay, next week. So I will see you again on this Thursday where we will cover the new chapter. So next Thursday, let me look at the calendar. Okay, today is 17. So next Thursday, I will see you. Thursday is 20 of November, right? So we will have a lecture as usual. Okay, I will cover chapter 5, okay, which is trigo. Okay, but next week, right? Supposedly on 24th of November, okay, it's a convo week, right? So we don't have venue for physical class. Okay, but I will still do next Monday. I will still do online class, yeah? I mentioned this to the management already. So 24th of November, I will still do online class, okay? And also the same week on Thursday, which is 27th of November, I will also do online class, okay? But the following week after that, Monday on 1st of December, class, Monday on 1st December, there will be no class, yeah? Because I already do this in advance, okay? Similarly, on Thursday of 4th of December, okay? We don't have class as well because I already do this in advance next week, okay? But during this week, you will have your test 1. Test 1 will be done physically. Okay, I bet you got the notice in the Teams already. Test 1 is physical, right? On Friday, 5th of December. Okay, it's 1.5 hours. The topic that will be included is also mentioned, already mentioned. The topic that will be included in your test is this: functions and graph, polynomial, and the rational function that we just learned today. This will be tested in test 1. Okay? And it will contribute 10% class. 10% for the course. Physical, yeah? 1st of December on Friday. I won't be there. Mr. Amiro will handle everything together with other groups as well. So not just your class. They combine everyone during the test. Is that clear? Okay. So for the link for next week, I will update next week. Okay. Thank you, class. I'll see you on Thursday then. Bye.
Okay, Miss.
Yes, any questions?